Welcome back to this new video. So in this video, we'll learn how to create custom layouts in Jetpack Compose. So sometimes the row, columns, and other standard layouts are not enough. So making your own layout that fits your design is an essential skill to actually have. So with Jetpack Compose, that is really easy to achieve. Let's explore how we can actually create our own custom layouts. And in this video, we're going to create a circular actually offers a three-step process, converting a composable function to a drawing inside a screen. So we have three-step process that is the composition. So the composition is going to decide the UI tree to be shown actually. So if we have an if statement to decide if to show or not a button, so basically we can use that to decide inside the composition. Then we have the layout phase. So this is actually going to calculate the size and how to show the UI tree inside our composition. Then we have the last phase that is actually drawing. And this one is going to render the UI tree on the screen, which we have already calculated the size and also decided what to show. So here now we are going to draw this inside our screen. Now let's focus on the layout phase of the composable function. So in this phase, we have a three-step process. The first step is actually measuring the children of that layout composable. So let's assume here we have a column and text fields. So if we have three text fields, then the column is going to measure first these three text fields and understand its sizes. Then after that, it's going to decide the size of that particular layout and how to actually position itself. That is actually positioning itself inside the XY coordinate. So this is the tips which is going to be taken inside the layout phase. Sounds complex, but it's really easy with Jetpack Compose. Let's see how we can actually achieve this. Okay, now let's create here our circular layout. So let's directly go inside here application and you can create a new project because this one is just an empty project which I have created. So the first case, I'm going to create here a new coding class or file and let's call this circular layout and we can select file here. Okay, now let's create here a new composable function and we can call this circular layout. Okay, so I'm going to pass in here several parameters which we are going to need. So the first parameter here is actually the radius. So we have to use the radius because we're creating this inside a circular. So we can create and make a fixed radius. And this one is going to be in terms of dp. Okay, so by default, we're going to use 100 dp for a case. The next case is we actually need the content. And this one is actually the composables which we want. So we can call here composable. And here we can return unit. So basically to pass in the children here, you can have anything else that you actually need. Okay, and basically here we're going to use the radius in terms of dp. Now we want to convert this to pixel actually to use it inside our calculations. So basically we can use this in Jetpack Compose and get the density. So let's call the density here. That is going to help us when we want to actually convert. Okay, the next case here is we are going to use the layout composable function. And you can see we want to pass in here several things. So the first case is you can pass in here the content, and that is the content which we have. And here we can open up, that is the measure policy. So when you press Command P, you can see here we have the content and also we have the measure policy. So the measure policy is actually going to measure that composables. And here we have several parameters which we have. The first parameter is the measurable. And the next case is the constraints. So the parent constraints. Okay, so you can see here actually we have the list of measurables which we can use to actually measure or the children which we have. So if we have 10, then we're going to have 10 items. And here we have the constraints. So this one is going to be the constraints that we can use to actually constrain our children. So we're going to see how we are going to use this. Okay, so the first case is we want first to get the radius in terms of pixel. So for this case, we can call here a radius and we can easily convert this by using a width function. So we can call here our density and we want to convert the radius. So we can call the radius to px and this one is going to directly convert it. Okay, so inside here, we want to measure now the children. And in order to measure the children, we can loop around all the measurables and actually get our measures. So let's call this placebo. Let's call our measurables and we want to call here map. And here what we want to do is call the measurable, but this as this way. Now we have our first phase here, or our first step is actually measuring the children. So we are calling here measurable.measure. Now it's going to measure everything. So we can use the constraints, and now we want to get the constraint to actually measure that children. So if it is 10 by 10 dp, then it's going to measure it. But one thing here, if we leave this as how it is, it's going to make this to take the whole size. So it's going to fill actually the max size. So for our case, we want to make this a loosey constraint. So we can call here .copy and pass in here the mean width to be 0 and the mean height to make it 0. So this way, it's going to decide its own size based on the constraints that is going to be given. Otherwise, it's going to take up the max size. So this is the first step which you have to measure. We can call here our layout in order to remove those squiggly red lines. So you can see after we measure the children, then we can try to place this. But for our case, because we are creating here a circular layout, we want to add several things that we want to get first. So the first case is we want to get the max child width and the height in order to decide the size of these circular layouts of our case. So for this case, we can create here a simple function. So let's call this a simple variable, max child column width. So we can call here our placeables and get the max of, okay, the next case is we want to get the height. Here we can call .height. Okay, so we are getting here the largest child width and height. Now the next case is we want to calculate the layout's desired size. We can get first the diameter, actually take 2 times the radius in order to get the diameter. Then we're going to add the maximum child in order to determine the desired width and the desired height. So for this case, let's create here our desired. So for this case, we are going to take 2 multiplied by the radius to get the diameter here basically. So radius px. Okay, so we converted this to pixel. Then we can add here with the max child width. So you can see here, and we can convert this to int. And similarly, we can get the desired height, and we can get the max child height. Okay, now we want to get the layout size within the parent constraints. So for this case, let's call here our layout width. So we can call here our constraints. And we can call here our desired width. And similarly, here is we want to get the height, and we can constrain the height with the desired height. Okay, so we have taken place all the necessary things. The next case is we want to get another thing that is actually the center of our layout. So not the center of the screen, because we want to get the center of that particular layout because we are going to have a box. Now we want to decide inside that particular box, we want to get the center in order to lay out everything. So for this case, we can call center X. So let's call here our layout width and divide this by 2f. And center Y, here we can call our height divided by 2f. Okay, so inside here, we are going to get our layout width and our layout height. Okay, now let's add the names to the color parameters to make this more explicit. Okay, so here we have the layout width and actually the layout height. Okay, so another case here is what we want to decide is the angle increment. So the number that we are going to use, because we want to spread them inside a circular positions. So we want to determine each angle that is going to be used in order to place each children. And for this case, we can get the total angle and divided by 360 because all the cycle is going to have 360. So for this case, we can get the angle increment and basically take a 360f because that is the total angle that is going to be maxima, and divide this by the size of the items which we have. So if we have 5, then we can get that, or if we have 10 and so forth. So we're going to decide the angle increment by taking 360 divided by the placeable.size. Now for this case, we want to look around all children here and actually decide now their XY coordinates, because here we are going to have a polar coordinates. Then we have also the Cartesian system. So for this case, we can use the placeable, and we want to go for each index so that we can get the index also. Okay, the first case is we want to get the angle of each item or each children. So we can get this by using the index multiplied by the angle increment. Okay, so if it's going to be the first one or it's going to be the second one, then we can get the angle. So we're going to start from 0. Now the next case is we can divide these angle increments actually and make it to a radian in order to use it inside our formulas. So you're going to see why. So let's call this radians. So we can use here the math and we can convert this to radians. And here we can call here our angle increment. So we can call here our angle because we have already decided here. And we can change this to double. For example, when we have a point that is defined by a radius and an angle, so the conversion to Cartesian coordinate system is going to be given by, for example, the x, we are going to take the radius multiplied by cosine of that particular angle. And getting the y coordinates, then we can use the radius multiplied by sine of that particular angle. So we're going to use cosine and sine here in order to allow us to convert the polar coordinates, the angle and radius, into xy position on the layout here. So for this case, let's use simple mathematics, where we can decide the x position of this. So the first case, we want first to decide the center and also add this, because this the position of this is the xy coordinates is going to start from 0, 0, and that is going to be the top left corner, but we want to position this at the center. So that's why we're using the center x in order to decide this. Now we can get that particular location by using the radius in terms of pixel, and we multiply this by the cosine. So we can use here cos and pass in here the radians, that is the angle which we have. Okay, now we can convert this to float. Now another case is we want to get the placeables. So we can use placeable.width divided by 2. Okay, so this one is going to offset this because the first case is going to be drawn in. So you can see if we have here layout, you can see this one is going to be drawn in the top left corner. So we want to center it inside that particular width. So if we have a text, so the text is going to be positioned at the top left corner. So instead, we want to center it directly to that point where we are going to draw. That's why using here placeable.width divided by 2. Now, similarly for y, we are going to use that. So let's change this to y. And here it's going to be center y. And instead here of using cosine, we are going to use the sine in order to decide this. Now for here, we can use the height and position everything to the center. Now we can use to place each children relative to its position. So we can call here placeable.place. So there are different. So you can use here the play. This one is not going to account from left to right. So if you have a layout that starts from left to right, so we can call here place relative. And this one is going to provide this. So the first case is we can provide the x. So we can use here x.toInt. And the y also, we can use y and convert this to int. So as simple as that, we have here our custom layout. Now the next case also here, we can use the modifier. Let's pass in here the modifier and actually make this modifier be used there. Now we can try to use this inside our main activity. So let's directly go inside here main activity. And instead here we can call our circular layout. And you can see we have our composable. And here we can use, for example, the modifier, because let's go here modifier.padding and pass in here the inner part to remove the error from the scaffold here. So now we have the scope where we can use our circular layout. Okay, so here we have our circular layout. We can try to run this inside our application, or we can try to just call it inside here preview. So let's do this because here we have our preview ready. So we can call here our circular layout. And directly here we have our scope, and we can just call inside here different things. So we can try to create something like a clock face. Let's call here a repeat function. And basically we can call this 12 times. Now we can create here a text or anything else. Let's create here a box, for example. So we can give it a size of 50 dp, for example. And we want to clip this in a circular shape. And we can give it a background. So for background, we can use here a color scheme and call the surface variant. Okay, so everything here is looking perfectly. Now we can try to call here our text. Let's create here a text on the text part. So we can add one here, convert this to string. Okay, now let's try to preview here. Okay, so you can see here, these things are going to be out of bound. So I think we can try to align it. Let's keep the alignment. So we can call here the content alignment. Let's align it to the center. Okay, now everything is looking perfectly here. So you can see we have the numbers which are inside the regular shape. But one thing, I want to have the ability to actually give the start angle. So I want, for example, this one here, because this one is the way it's starting to draw. It should be given in a certain space. So for example, one is going to be around here inside the clock. That is just our normal. So we can modify here our circular layout. Let's go inside here. And one parameter which I'm going to add here is the start angle. And this one is going to be a float. And by default, we can give it 0f for our start angle. Okay, so here for the angle which we're going to have, let's keep this and call here our start angle and add the angle here in order to also accommodate that. So for this case, we can just go back inside here, our preview, for example. And for our circular layout, we can define here the start angle. Let's give it 300f. Okay, so you can see the start angle now has affected this. You can see it's starting here, 1, 2, 3, and 9 and 12. So everything is perfectly aligned as how we actually intend. So guys, this is it. It's actually easier to create your custom layout. So if you find this video helpful, please don't forget to provide a like, subscribe for more videos. So I'll see you in the next time. Bye bye for now.